Lesson of today, 5.4, arithmetic sequences. So I guess the easiest way to explain it, guys, it's a pattern. There's a pattern happening here. It's just a list of numbers that are connected by a pattern. So if you see it in a table, it might look something like this. We have the term number, which is basically the order. This was the number 1, number 2, number 3, number 4. And we're looking for how is it changing? How is it growing or getting smaller? And when you look at it, it looks like they're all doing the same thing. And for it to be arithmetic, they need to all do the same thing. You're either adding a positive or you're adding a negative number every single time, and it's always the same number. We call this the common difference. So in our equation, we're going to call it D, the common difference. And it's very important that you find that whenever you have these patterns, okay? Now, let's take this for example. Here's our, I used to write this down a lot, my first term, second term, third term, fourth term. The book uses this, A1, A2, A3, A4. So if you wrote this down, it would be A1 is 9, A2 is 4, A3 is -1, A4 is 6. This is a lot of vocab, just getting used for you guys to see this. But it doesn't change what you're still looking for. You're still looking for the common difference. So this time it's not growing. This time it's getting smaller, which means you're adding a negative number. So from 9 to 4, from 4 to -1, from -1 to 6, it is going down by 5. So we say that the common difference is -5. Now, what if they want you to write a formula? If they want you to write a formula, I want you to remember this, mx plus b, because it's very similar to what we're going to be doing. Mx plus b is the linear equation that we used in the past. Now we're going to use something a little different, okay? We're going to use something called the explicit formula or the recursive formula. So these two formulas I need you to write down. Whenever you're doing arithmetic, these are the two formulas they're going to be using, okay? Now, if you notice this whole n minus 1, the reason it's an n minus 1 and not just an n is because there is no zero term. There is no a0. There's a1, a2, a3, a4, right? Like I showed you earlier. But there is no a0. Now, if you're in my class before, we used to pretend there was, and we would find it. But this book doesn't have you use it, so we're not going to find a0. Okay, now, let's write the equation for this. All right, a1 is 46, so I'm going to put that right here in my formula, my starting term. Now, what is the common difference? What are these numbers changing by? So it's usually easiest to do the first two. From here to here, what has happened? It's dropped, so we're subtracting, so the difference will be negative. And it seems like it dropped 20, so it dropped -20. N minus 1. And guys, that's the formula. Now, we don't leave it like this usually. What will generally happen is you'll distribute. So you'll have -20n plus 20 plus 46. Then if you rewrite that, you get an equals -20n plus 66. And that would be the way you write the formula. You distribute that number and you end up with this. These two are like terms, so you add these up and you get 66. Now, if you remembered, if you were in my class before and I told you to find a0, guess what a0 was? Go backwards. What would be the number, if there was an a0 in this pattern, what would be a0? Yeah. So if you use the old method I showed you, it'll still work. It'll still work using a0. If not, you can use this. Now, recursive formula, this was actually easier. What was the common difference? -20. So you just put -20, and that's it. You don't do anything else. That's the recursive. The recursive just tells you how to find the next one. So for example, let's say I wanted to find a5, right? Well, you plug in a5. Oh, wait a minute. What's a5 minus 1? A4. Wait, what's A4? Negative 14. So how do you find the next number? Negative 14 minus 20. What's negative 14 minus 20? Negative 34. So A5 is negative 34. That would be the next number on the list. That's usually what they use this formula for, but I think for the most part, they're just going to ask you to write the equation. I don't think they're going to actually ask you to use it to find the next term. And if they do, guys, just follow the pattern. If it's dropping by 20, what are you going to do here? You're going to drop again by 20, and guess what you'll get? Negative 34. Okay, so those are the two formulas. Explicit, recursive. They're going to ask you for both. Now, what if they give you one but not the other? If they give you this, but they want this? All right, well, what's the only thing you need here? The common difference. So if you look back here, where did it go? It went at the beginning. It went next to n. So what number do they have next to n? 4. So your formula, if they want the recursive, is just with a 4. So you just take the common difference and put it in, and that's it. You don't need to find A1. Okay? Here. Well, what if they give you A1 and the recursive, but they want the explicit? Well, if they want the explicit, that means they want this formula. Okay, so if they give you this information, where do you put it? Well, the common difference is 8. Remember? That's the number that went in the recursive. But in the explicit, it goes first. But the explicit also wants A1. Well, they tell you what A1 is. All right, so we simplify it. We distribute. You're going to leave 8n alone. Negative 8 plus 12. It's going to be, I think, positive 4. And there you go. There is your explicit formula. Now, another thing you can do with this is make the sequence. So if you're starting with 12 and the common difference is 8, that means you're adding 8 every step of the way, right? That's the pattern. That's the pattern that this and this are describing. So that's another way to do it.